Okay. Do you have a anyway? So good morning, everyone, once again. No? So thanks for coming last Friday. I was there, but I was not able to talk or greet any one of you because I ran out of time. No? I was supposed to stay later, but I had to do something, so I had to leave early. Anyway, sometime we'll just see each other again. Hopefully, when we will do lab schedules. No. Do you have questions about last meeting? So last meeting, I introduced you to a history, no, especially during the modern period, no, and a very significant development came during the early 19th century in Great Britain, no, when Charles Babbage invented the analytical engine, and also at the same time when a mathematician from the same university, Cambridge University, no, recognize the work as something very useful and which can be used to solve day-to-day problems in math. No? So her name was Augusta Ada King, Countess of Lovelace in Great Britain. So these are the two most significant inventions during that time. No? There was a computer and there was a computer programmer. Do you follow? No. And then also later in that same century, 19th century, no, in the US, no, the punch card tabulating machine was invented in 1884 by Herman Hollerith. Now, during that time, the US has a lot of migrants, no? So they have to do a census, and recording is important, no? So one way to do to hasten the recording was to use a punch card tabulating machine. So here is a modern IBM punch card, no? Here's how it looks, no? And then this was already the form that was used in the census. Do you follow? Okay. So Herman Hollerith later founded the tech giant IBM. IBM is still around today, no? Because it invented the IBM PC, okay, which is now the ancestor of our modern computers. Yeah? Your laptops, no, Intel-based, no, computers are based on the IBM PC. Okay, now as I've said, we will look at the evolution. We'll just not mention the event. We'll look at the evolution and see how computers came to be, right? So let's look at now. If you look at our next, there's the design of the analytical engine. Okay. Here it is now. There are two main components. The store is made of the Jacquard's loom and the mill. Now let's look at that. No? The store. Eh, wala siya, no? Jacquard loom na lang. Sana mayroong picture dito, no? Let's look at the Jacquard loom na lang. Anyway, Jacquard's machine was used as the store. Okay, this is the Jacquard loom. Okay, so the programs are stored in a series of punch cards like this, no? So ito yung the program are stored here. The program is stored here. There's another version of the Jacquard loom. This is called the store. Okay, do you follow? Each card can contain one instruction. Okay, have you all done programming? By the way, in senior high? Who has not done anything, any programming? Can you chat me? Send me a message. Okay, I assume you have done programming now. So, where do you save your program? As a file in your hard disk, right? Or as a file in your USB card. During those times, the programs are stored in a sequence of cards, wooden tiles like this. Okay, and they are read each one card after another. Okay. By the way, before they're loaded, no, it is said that there's an attendant. The attendant is actually the operator of the machine. The attendant inspects the cards one by one. Okay? Pwede paki-mute mo na. Okay. Okay, so the attendant looks at the cards inspects the cards for errors before loading them into the bin. And it is then that when it's loaded that the process starts. No? The process is such that it's a repetitive process that reads and loads the store one card at a time into the mill. Okay? So how does the mill look like? No? Meron ba tayong analytical engine with Jacquard doon? Wala, no? There's no picture with the Jacquard loom. Ito na, this is a better punch Jacquard loom. Okay, this is the Jacquard loom used in the analytical engine. Okay, wala tayong picture, no? Anyway. Open image. Ganyan. We follow. So these are the two main components of the analytical engine. This is the mill and this is the card loom or the store. No, ito yung the mill, the store. The programs are loaded one by one and read each one to run the store, the mill. Do you follow? No. This is the store and this is the mill. Okay. This is like the hard disk and this is the CPU. Do you follow? No? Okay. Let's close that for the moment. Okay. So the machine is also able to write values into the store. The mill, no, is able to store by punching holes onto cards, which are going to be read later. So the number system that is used is decimal fixed point. We will also describe what fixed point is later, no? Decimal fixed point representation. Okay. The store is the main memory capable of holding 1,000 numbers of 40 decimal digits, which means that there are 1,000 cards. Okay. And each number is 40 decimal digits in fixed point. So there's a fixed number of decimal places. No? Okay. The mill, the arithmetic unit, would be able to perform all the mathematical operations. No, plus by certain operations like shifting to the left and shifting to the right, and even optionally square root. No, it's like the CPU of the modern computer. Any questions so far? Sana ma-embed natin yung ano dito, no? Yung images of the store and the mill. Okay? I'll do that later, okay? Now, you can look at the next, programming the analytical engine. How do we program the analytical engine? Okay? So, basically, programming is done by using cards. So, ganito yung story niya, no? So, it's a series of cards, no? Of different types, no? And contents, no? Now, during the emulation, it's actually a simulation run of the engine. The chain is represented by a series of lines in the text, no? Ganito. But actually, these are, during emulation, no? Ito yung series of lines in the text, but these actually are stored in one card each. Do you follow? Do you follow? Okay. Okay. To run a calculation, no, the card chain or the series of chains is prepared by the analyst. So compute programmers then are called analysts, no? And then submitted to an attendant for checking. It's like, you know, script editing of news contents, no? Do you follow? The author writes the news, and then the script editor checks for mistakes. So the attendant checks for mistakes from the series of cards submitted by the analyst for possible errors, no? So kung may error, they will have to change it all deck at a time, no? Hindi pwedeng, you can't remove a card and then replace it with another. Okay? After completing all the requests, no? By the attendant, the chain is now loaded. Assuming it's free of error, it's now loaded into the store, okay? And which causes the card reader to begin the process, no? Do you follow? Do you get the point how it runs? Okay, so the program cards have two forms, no? There are two types of program cards, number cards and operation cards. Do you follow? Number cards are started with commands N. N stands for number. For example, when you say N001000, this will load. There are, remember, 10,000 columns in the store. Do you follow? Because 10,000 ba 1,000? Let's look at that. 1,000 lang pala. The 1,000 numbers of 40 decimal digits. So there are 1,000 there are 1,000 columns, no? And when you say N001, this loads a value of 0 to the first column, okay? Because the columns are labeled 0 to 999, 999, because counting starts at 0. Do you follow? So it's like a worksheet, okay? And in fact, in our simulation, we will use a worksheet, right? Do you follow? It's like a worksheet where we have 1,000 columns. Okay, so when you say N001, 0, the value 0 is stored in column 1. When you say N275, 10,000, the value 10,000 is stored in column 275, or that's the 276th column, no? Assuming everything starts with 0. Okay, any questions? And then when you say N302, -1321, a negative number is placed in column 302. Okay, do you follow? Do you get my point? Okay, so this is a simple program which stores 3 variables. Do you follow? The first variable is N1, the second variable is N275, and the third variable is N302. Do you follow? No? Can you figure it out? No, like variables in C# or C++, you use letters or names, no, to name logical names to name your variables. Now, in this case, no, during the analytical engine, variables are named N1, N0, N2, like that, no? Do you follow? So that if you look at the actual program by Lovelace, no, Ada Lovelace, no, nandito ba 'yon? So nandito yung actual program ni Ada Lovelace. Okay, so this is column 1, column 2, 1, 2. These are the different columns. Okay, and these are the commands. First is times, next is divide, and so on and so forth. No, so the variables are stored in columns. Okay, we are going to do that in Excel. Okay, that's why I'm introducing this to you, because we are going to do that in Excel. In fact, dito dinescribe pa niya yung operation, no? Dito niya dinescribe statement of results. What is going to be done? And the results are also stored in variables. For example, W1 is actually N1. W2 is N2. No, W3 is N3. And the results are stored in W21, W2, and so on and so forth. Okay? Do you follow? Now, Ada Lovelace calls them W to stand for working variables, which means they are variables which can change. Any questions so far? No? So ganun, no? Now, so the numbers, the commands, the program can contain 2 types of cards. Number cards, which store values into variables, and operation cards, which indicate operations. Okay? Sana hindi natin nasira ko na ba? Okay? Operations such as plus, minus, times, divide, or sometimes even square root is there. And 2 additional operations, shifting to the left and shifting to the right. Tatlo pala, hindi lang pala dalawa, no? Number cards, operation cards, and variable cards, okay? N is used to store values or values as into variables, no? Into the store itself, no? To initialize values. It's like an assignment statement, okay? The command N is like an assignment statement when you say X is equal to 2. Do you follow? So when you say N0010, we say N001 equals 0. When you say N275 equals 10,000, we say N275 equals, this is an assignment statement, no? The closest equivalent. Okay, and then the operations are plus, minus, times, divide. So if you look at the program by Ada Lovelace, no? The first column is the column of operations, times, minus, divide, times, minus. Okay, so what is involved in the times? W3 and W, what's this? Let's can enlarge this. Do you follow? So variable 2 and variable 3. Hindi pala W, no, variable pala, no? V pala talaga, no? So we multiply V2 and V3. Okay, so the result is, wala, hindi pa niya sinabi, no? And so on and so forth, no? Do you follow? So this is the program, the actual program written by Ada Lovelace to compute the nth number in the Bernoulli series, no? Bernoulli machine. Okay. So ganon, no? So you have plus, minus, times, divide. Okay? Now, ganito yon. Once the mill has been set to perform a given mathematical operation, it will do the operation of using the pair of arguments. Okay? Here's an example. We have an example ba? Ito, divide. When you say divide, okay? Okay? When we say N1, 1,000. Okay? N2, 28. When we say divide, okay, what is going to be, it will automatically divide what was loaded. So before, automatically, no? So N1 will be divided by N2. Tama ba? Okay. Okay. Nakabaliktad, no? Okay. Okay. And then there are variable commands, L and S. Any questions, no? So una yung parameters, the parameters comes before the operation. Okay. Ingress axis and the, okay. So anyway, tingnan nga natin, may kulang pa tayo, no? We haven't described the analytical engine yet. The mill, may kulang pa, no? Anyway, let me look for nandito lang naman eh, no? The design of the analytical engine. Tama ba ito? Sorry, no? I didn't get it. Ito, the design of the analytical engine. No, the ingress and egress axis, no? Dito muna, balik ko muna tayo, no? Kasi hindi sinabi dito ang ingress and egress axis. Let's just Google it. It's one of my, you know, I'm sure it's in one of these, you know, no? Nalimutan ko na kung saan ko nalagay, no? I-Google ko na lang, no? I think I have a source which comes from CLSU, no? I'm sorry, no? Wala ko yung material, no? Maybe I've deleted it. Let me look at from my files. in structure of the analytical engine. Sino? Ah, kami. Ah, okay. I forgot the source, no? Egress and ingress axis. Let me just add ito, no? I should have put this, no? Programming the analytical engine. It's here, no? By the way, no? Okay. So ito. So it's here in our course. It's called programming the analytical engine. And then we have here the analytical engine programming cards, no? Before this. Okay. So these are the basic parts of the analytical engine, no? First, we have the prime ingress axis. We have the ingress axis, 1, ingress axis 2, and egress axis and ingress axis. What are these? These are actually gears, no, in the mill, which rotate depending on the values that are stored into it, no? Okay. So these are the basic parts of the mill. Okay. So the ingress axis is used for input. So for example, you are going to divide two numbers. The first input comes into ingress axis 1. The second input number goes into the ingress axis 2. Okay. When the division is done, the result is stored in the egress axis. Okay. Do you follow? So what it really means is when you say ingress, no, which means input, no, egress means output. Do you follow? When you say x is equal to y plus 2, okay, y is the first ingress, 2 is the second ingress, and x is the egress. Do you follow? Do you follow? Now, the prime ingress axis is used, no, in case of large numbers, because Charles Babbage intended to okay, a quotient of 100, because he wanted it to compute, to be able to compute, no, a quotient of 100 digit divided by 50 digits. So how much is that? No, so the excess will be in the prime ingress axis. Okay, and the result also will also be on the excess of the result will also be on the prime egress axis, no? So in case where a very large number, okay, bigger than 40 digits, is going to be divided by a 40 digit number or by a 50 digit number, okay, the prime ingress axis is used, no? But normally, no, the ingress axis 1 is stores the first variable, the ingress axis 2 stores the second variable. Okay. There's a run up lever. Okay, what will the run up lever do? The run up lever will determine whether the value of the last result is positive or not. Okay, the sign of the last result. Okay, for example, if you do the equation 4 minus 9, the run up lever will be set because it's negative, which means when we say set, no, the run up lever will become 1. When we say reset, the run up lever will become 0. Okay, do you follow? When the result of the last operation is negative, the run-up lever will be set. Okay. When the result of the last operation is 0 or positive, the run-up lever will be reset. Okay. Remember binary terms, no? When we say reset, we mean a value of 0. When we say set, we mean a value of 1. Okay. So ganito yung ganito yung diagram that describes the the egress axis. So let's look at the mill. Ito yun, I'm sorry, this is the differential engine. The analytical engine is this, no? So ito 'yon, no? So may apat na, no? There are 4 columns, no? Tingnan natin ito mag-large. Okay, if you look at that, no? So there are 4, there is one of these, no? Ito siguro yung how many? This is the egress, prime egress. This is the egress axis 1, ingress axis 2, and this is the prime ingress axis. No? So the main wheels that are used is ingress axis 1, ingress axis 2, and ingress axis 3. So they are rotating gears. No? Do you follow? Do you follow? Anyone? Okay. So number cards are assignment statements. Variable cards. Okay. They are used to load and store. No. Operation cards are used to signify operations such as plus, minus, times, divide, and shifting. No? Okay. So let's look at the programming. No? Ano siya i-program? Okay. Nandito pa na pala, no? Nandito pala sa taas. I'm sorry. No? Let's look at this. Nandito na pala. It says on the same document. No? Okay. So the variable cards are L and S. L means load a value from the store into the mill. When you say, depending on the series, no, the first L we load it into the first ingress axis, and the second L we load it into the second ingress axis. No, do you follow? Okay. So automatic sa kanya yun. The first L goes to the ingress axis 1. The second L goes to the ingress axis 2. Okay. So here's an example. CF, by the way, is count forward. CB means count backwards. This is an operation card. Operation card CF, CB. Okay. We'll look at that later, no? Okay. So for example, L001 loads a value. Okay. Loads a value to address 00 from address 001. Do you follow? S002 stores a value to address S002. Okay. P prints a special of the result of the egress axis. Do you follow? H halts. No? CF means for looping ito, no? Count forward and count backward. We look at the example later. No? You know what looping is, right? Diba? Sa C# plus C++ plus C or minus C. No? Here's an example of how to compute 500 minus 30. When you say N001 500, we mean this is an assignment statement. N001 equals 500. And when you say N002 plus 30, we mean the variable 002 stores 30. Okay. When you say divide, okay, sets that machine to divide. Okay, do you follow? And when you say load 001, okay, the value from the store, which is address 001, will be loaded into ingress axis 1. When you say load 002, okay, the value in 002 will be in ingress axis 2. Okay. Okay. And so on and so forth. No? There's an example. No? Okay. No, una pala yung ano, no? Una yung operation before the parameters. Okay. So operation first before the variables. No. Okay, here's an example to compute 4th factorial. Do you follow? We have this in our worksheet, no? In Excel. We'll do this in Excel. We'll trace this in Excel. An example of the 4th factorial in using the analytical engine. Do you follow? Any questions? Any questions, class? So if you have no questions, we'll proceed to the first program, which is the fourth factorial. Okay. It's in our regular, the fourth factorial for the analytical engine. Can you download this? Okay, download, no? Fourth factorial for the analytical engine. Okay, do you follow? So the analytical engine looks like this, no? Ito yung mill. There are two parts, no? The mill and the store. Do you follow? The mill has ingress access 1, ingress access 2, and egress access 1. Okay. This is the store. We start from 0, 0, 0. Now, by the way, ang sa ano is V, no? Can we just change this to V? V kasi ang ginagamit ni Ada. Variable. Okay. This is how the Lovelace labels the, no? The store, no? Para it looks similar to this. Do you follow? With loop pala ito. Is this with loop? Without loop tayo, no? Dalawang versions kasi yun. We have a without loop. You can download this. The first worksheet is without loop. The second worksheet is with loop. Can you just rename this, no? Kasi we'll follow the convention established by Ada Lovelace. I'll upload that anyway, no? I'll update the file there. Okay. Okay. So anyway, here's the values, no? V00 is used as the next multiplier. V001 is used as the constant decrement of 1. Do you follow? And V002 is the partial product. What is the fourth factorial, by the way? Anyone? How do you compute the fourth factorial? Okay. The fourth factorial is 1 times 2 times 3 times 4. Do you follow? No? Everyone? So what is the third factorial? Can anybody chat me what the third factorial is? 1 times 2 times 3, that's 6, no? 1 times 2 is 2 times 3, that's 6. Yes. So kung ibig mong sabihin, third factorial, this is the product of the first 3 numbers. When you say the nth factorial, we mean the nth product, the product of the first n numbers, starting from 1 to n. Do you follow? No? So this is the fourth factorial, used as an example, no? There, but the example used by Ada Lovelace is the Bernoulli series. Ito, the fourth factorial is easier, no? There are 2 versions of the factorial program. There's a without loop and with loop. You know what looping is, right? Everyone? No? Repetition. If you've done a little programming, you'll also be discussing this in your other class, by the way, no? Okay. So the advantage with the looping is that there can be a variable n, no? Which means that you can use it to compute different factorials, not just fourth factorial, no? 5, depending on the value of n, you can compute the 5th, the 6th, the 7th. Okay. Okay. So you have here N004. I-erase na lang natin ito, no? Let's erase all this so we can trace. Okay. Ito yung pinaka-last, B999. Okay. Basta galing ito sa store, ito yung mill. Ang mill, 3 columns lang. Ingress access 1, ingress access 2, ingress access. Okay. When you say N004, okay, we will give this a value of 4. Ito. Do you follow? Tama silang gones, no? The third factorial is 6. 3 times 2 times 1, okay? Okay, when you say N004, we mean that the variable 0 will have a value 4. Okay, it's an assignment statement. Okay, when you say N001 is 1, we say, so this is the fixed decrement. Okay, and when you say N002, 1, this is the first partial product. You follow? Okay, we are tracing how the mill and the store works. No? That is the same way that Ada Lovelace did. Medyo complicated lang yung kanyang ano, yung kanyang computation. Okay. Medyo complicated, no? Meron pala tayong ibang source, no? Okay. May iba rin siyang ano, no? Okay. So anyway, we'll not look at the Ada Lovelace ano, worksheet, no? Kasi mas complicated yung sa kanya. Okay. This is our worksheet, okay? Times, which means that it will do a times. And the multiplication is done during when the second variable is loaded automatically, okay? So times means that the mill is set to do a times after the second parameter is loaded automatically, okay? So L002, L002 being the first L will set up ingress axis 1. L000 being the second L will set up the ingress axis 2 and will compute the result in egress axis. Egress means output, ingress means input, okay? So L002, which means that, okay, egress axis 1 will retrieve the value of 1. Any questions? Do you follow? Why is this 1? Anyone? Because when we say L001, we say load ingress from the value from the variable 2. Ito, this is a variable 2. Do you follow? And when you say L00, we load ingress with the value of variable 0, which is 4. Okay? So siya, oh, this one goes there. Do you follow? Remember that the first L after the variable card, rather the operation card, will go into ingress axis 1. The second L will go into ingress axis 4. And upon loading of the second parameter, it will compute the result. What will happen to this? This will become 4. Do you follow? Di ba? Yun yung sabi dito sa ano? In our ano? Where's my... Bakit nawala? Erase mo. Ito pala. Ito sa kabila na. Let's close this first. Okay. Loading the second argument into the mill causes the multiplication to be performed, after which the prime egress axis and the egress axis contain the product. Do you follow? Like this, and you have times L0 and L1, okay? The L1 will also fire the operation being indicated, which is times, no? And after which, right after which, no? The egress axis will contain the specified result. Do you follow? No, nandito yan, no? Sa ating source, programming the analytical engine, and then the analytical, dalawang source ito, no? This is the programming the analytical engine, and this is the analytical engine with programming cards, no? Do you follow? Dapat na name ko yun, no? Oh, the Analytical engine program with engine programming cards. Okay. Yeah. Do you follow? No? Okay. Okay. Any questions so far? So every time there's a numeric computation, okay, the engine is set to load the first parameter into ingress access 1 and to load the second parameter into ingress access 2, and at the same time do the actual computation and compute the result, store it to ingress access 4. Do you follow? Any questions? No, chat me if you have questions. Okay. So anyway, when we say S002, this is a variable card. S means store, L means load. Okay, do you follow? Store the egress axis. Baligtad dito ngayon. This is the other way. Store the egress axis to 002. So therefore, the variable 002 will now have 4. Do you follow? Do you follow? So this is our main source is Stanford University, no? CSU, Stanford University sample. Okay. So this becomes 4, no? Okay. No, dito pala. S002, dito, it's in this line, okay? Do you follow? Now, we say minus. Okay. So the next operation is going to be a minus. And then the first load is L000. What will be the value of the ingress access 1 here? Anyone? What will L000 mean? 4. That's from AJ Tabudlong and Ivan Lo. Yes, very good. There's so many of you there. No? The first one was AJ Tabudlong anyway. So this becomes 4. Why is that? Because we are going to load the variable 4. We are going to load the ingress access 1 with variable 0. So 4. So this becomes 4. Okay. And when you say L0001, being the second L, this will go to this column. No? What will be this value? 1 from Psych Casiple. Okay. Giancarlo More. And Earl. Who's Earl here? Can indicate your name, no? This becomes 1. Okay. Okay. What becomes of the egress act? This is the second L, right? So it fires the operation. What operation will be fired? Subtraction, right? So what's the result of egress access? AX 3, because it's 4 minus 1 is 3. There are so many of you there, I didn't catch up anymore, no? Sorry. Okay. And S000, what will happen to the 3 here? It will be transferred to variable 30. Take note, okay, V00 is our next multiplier. So our next multiplier is 4. After that, our next multiplier is 3. Diba? The next will be 2 and the last will be 1. That's how we compute the 4th factorial. Okay? So can we proceed now? No, I hope you're following. No? So very basic programming, no? Very basic programming. Times we are setting an operation card, right? So the first L will go to ingress access 1. What is L0? What is ingress access 1? 1. Do you agree? It's 1? Kasi hindi pa naman ito nagbago eh. Ano? L002 pala, no? L002. Nandito tayo sa times. L002. What's the value of L002? 4 itong 2 ngayon, no? 4. So this will become 4. Okay? 4. You follow? Yeah. L00, what will happen to this? What value will be stored here? Anyone? 3. Okay. Very good. I hope you follow. Those who didn't follow, and what will happen to the egress axis? Right away. Well, okay. And then we say S002. This will become our next partial product, which is 12. Okay? So, klaro-klaro siya, di ba? Now, the bad thing about this is, if you do not understand the structure of the machine, you will not be able to write a program. That's always the case, no? In the old computers. So programmers were smart guys because you have to understand the hardware. Unlike nowadays, we have third-level programming languages. You can write a C++ program without knowing what the hardware is behind. Do you follow? Nowadays, because of the high-level languages, now we have low-level languages in this case. No? Unlike now, we have high-level languages which hides the details of the hardware itself. No? We can write programs nowadays without knowing what the hardware is. But during those times, you have to understand the hardware before we can write the program. Okay. So the next is an operation card. It sets the ingress access 1. L000, what will be the value of this? What value of ingress access 1? That's 3. Oh, 3 galing dito, no? Good, 3. And then L001, this is the ingress access. What is L001? That is still 1. It will always be 1, okay? Kasi hindi naman dito nagbabago. 1 lang siya sa taas. Okay? And then what will happen to ingress access? This will become 2. Do you follow? And this will become 2 here. Any questions? So naging 2 na naman ang next multiplier, right? And then we'll do another times. So this will be L002. This is now 12. Okay. And then L00, which is the next multiplier, which is 2. Okay. And then this, since this multiplies, this becomes 24, right? And then S002, this becomes 24. This is our partial product. You follow? Okay. And then we do a minus of L000. 00 is 2. And L001 will always be 1. And it fires because we're in the second parameter. This becomes 1. Okay. And it will be stored at 1. So the next multiplier here is S00 pala. So the next multiplier will be 1. Okay. Do you follow? And then finally, we're going to do the last ano. Okay. So we are going to do a times of L002, which is 24. And then L00, which is 1. 24 times 1 is 24. And then we'll store it in the last result, which is 24. And we say P, print, which means it will now be printed to the last punch card. Do you follow? So the last punch card will store the value of 24. And we say bell, B bell, which means that the bell will be rung. Kasi they don't have a monitor, no? So the bell will be rung. And it should be a very loud bell because by this time, the attendant who was doing the is sleeping already. That's why they have a bell. Okay? It rings the bell to wake up the sleeping attendant and then it halts. H means halt. Okay? Do you follow? So this is a very slow machine. You could go to sleep before it's done. Okay? So do you follow? Okay. Let me have a drink first. Did anyone come late? Please tell me, no? I'm going to check the attendance again. Anyway. Okay, let's do a second version. You can download this, no? With loop. You know what looping is? What's looping? Anyone? If you've done programming, it's a repetition control, no? When you say a loop, you will repeat a certain part of your program given a condition, right? There are two types of conditions, no? A condition for continuation or a condition for termination. I think the condition here is condition for continuation, okay? Okay? Do you follow? Let's look at the CB, count backwards 8. Okay? Count backwards 8. Let's look at what it means, no? Kasi nandyan yan, no? CB is a command, no? Backing and advancing. Okay. Okay. Count backwards 11. Advance, skip forwards, no? CF means count forward or skip forward. Okay. It is a combinational card, no? How will it count forward? Once the value is set or not, no? Okay. The value of the run-up lever. Remember, there's a lever, no? That will, it's like a toggle switch. A run-up lever is like a toggle switch. Do you follow? Ganito, no? Which automatically sets on if the last value is negative. But if the value is positive or 0, it will switch off. Okay, digamon. See. So there's a run-up lever, right? Pag negative, if the result is negative, it will switch on. Okay, if the result is positive, it will, or 0, it's ano. Let's describe the run-up lever. Let's read that again. Saan yung run-up lever? Count forward, which means that if the run-up lever is set, it will move. This is an example of a loop, no? This is an ano. Okay, if it's 0 or up, it will count forward. 1, 2, it will halt. It will skip 2. Okay. So 1 minus 4 will set the lever off. Okay. 1 minus 3 will set the lever. 1 minus 2 will set the lever. Okay. 1 will not set the lever. 1 minus 1 will not set the lever. Okay, do you follow? Do you follow? So 1 minus 4 will set the lever because it's a negative number. But when it's 0, it will not set the lever. Okay, do you follow? So that's what we are to, when we analyze this. Okay, can I erase this now? Is the worksheet still clear to you? Okay. Is it still clear, everyone? Klaro pa ba? So the same way, this time, no? Baliktad na tayo, no? Our partial product is V00. Our next multiplier is V001. Our decrement is V002. We're trying to demonstrate this to show that we can use any variable. Okay? They follow. In programming, the variable name is not important. Okay? The logic is more important. Okay? So this is a loop, no, which repeats itself 4 times when depending on the value of 001. Okay, if you set n0015, it will compute the 5th factorial. Okay, if we set n001 as 6, it will compute the 6th factorial. Do you follow? Kindly chat me, no, if you have questions. Baliktad na tayo ngayon. Anyway, no, variables are variables. You can use them anyway. Binaligtad ko lang. Doesn't matter. N00 is 1. So this is 1. This is the partial product this time, no? And N001 is 4. This is our next multiplier. And N002 is 1. Okay? Can you still see the worksheet? It's a little smaller, okay? Palakihan ko ba? O, ganito na lang. Tama-tama lang, okay? Do you follow? So N001, 00, 1. This makes it 1. And since N001, 4, this makes this 4. And N002, 1, this makes this 1. Okay? So we designate the variables as follows. 000 as the partial product. Okay? 001 as the next multiplier and 0002 as the standard decrement. Binaligtad natin dito, no? Okay? You can do it any way you like, no? Okay? Do you follow? So the first pass, times. So you will have times. L00, what will this be? Can you chat me? Anyone? 1. Okay, kasi galing doon sa ano, 00. L001. This will become, what is this? 4. Okay, that's 4. Good, no? So, being the second L, it will do the multiplication. It will set the y-axis as 4 because it's 1 times 4. Do you follow? No? 1 times 4. Okay. And then we'll say S00, which means the y-axis will be transferred to S00. Okay, so this will now be 4. Do you follow? Okay, any questions on this? Klaro, no? Basta S gani, papunta yan sa galing, that comes from the y-axis. If it's S, okay? If it's L, it goes into the ingress axis, okay? Do you follow? And we'll do a minus, okay? First, L001, what's 1? Di ba ako nagkamali? Okay. Yeah, hindi mali, tama, no? L001. L001 is 4. Right? 4 siya, ito. 4. 4. L002. L002 is 1. That's always 1, no? So 1. It will now do a minus. 4 minus 1, the y-axis will become 3. Okay? And S001, this will become 3. Do you follow? 00 pala. Dito. S001, where is that? Yes. I'm sorry, no? I'm sorry. Medyo napalit this a little small. No? I'll expand this a little part. Okay. So S001, so this is 1. This will now become 3. Okay. So our current multiplier is 4. It now becomes 3. Okay. Any questions? Okay. 4 minus 1, baligtad tayo, no? Dapat CB8 kasi. Let's look at the, no? Let me look at the 1 minus 4 will set the lever. 1 minus 3 will set the lever. So baligtad tayo. No? Baligtad pala ito, no? I'm sorry. I have a mistake here, no? Kasi 4 minus 1. Okay. Yeah, baligtad dito. I'm sorry, no? Let's look at this. L00 002. You see L01. Okay. Do you follow? So L002, this is 1. Okay. Hindi. Okay. Count backwards. Count backwards, no? Kasi magiging negative 3. Count backwards 8. Okay. Sandali lang, no? I'll just look at the example because mukhang may, because it's 4 minus 1. Okay, we'll set. Results in a negative number. This statement is executed as long as the card value of n, when subtracted from 1, results to a negative number. So CB8, it should be a negative number. No? Okay. Anyway, ang problema ko dito yung negative, no? Because it's converted into a negative number. Okay. So L00. Ilipat niya yung ano. Okay. Ligtad yung ating ano, no? This is the actual, ano? So this is the times this subtracts. Let me just copy this, no? So we can trace. We can trace this somewhere on a different, ano? Okay. Let me trace the original example. Let's remove this first. This is the original example given by the, ano? Ito yung Jacquard Loom program. Okay. This is the original from the book, no? Because I've changed it previously, no? We follow. Let's trace it again, no? Using this version, okay? Because I have a problem with this, ano? Dito sa, ano? Okay. Let's trace this again. N004. This is 4. Then we'll have N001, 1. N002, 1. Okay. You follow. We'll find out which one is which later, no? And then we have times L001. 001 is 1. Do you follow? And L00, which is 4. Okay. Oh, sorry. This is the L001 is 1. And then L0 is 4. 4 times 1, this is 4. 1 times 4, S001. So this becomes 4. Okay. Do you follow? Do you follow? And then we have minus L00. L00 is 4. And then L002. L002 is 1. So baligtad talaga yung kanyang ano, no? This is okay. And sorry, baligtad, no? This is 4 here. We have 1 here. So 4 minus 1 is 3. 3. Okay. S00. So this will be now become 3. 3. And L00, 2. So this will become 1. And L00, this will now become 3. Okay. Count backwards 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Dapat 10 lang. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay? Balik siya dito. 10 lang ito dapat. Okay? So, tama. Form 1. My problem here is the run-up lever is 4 minus 1. Okay? 4 minus 1 is 0. The run-up lever is 0. Okay? Medyo, ano yung kanyang ano yun, no? Okay, let's read the count, the CF again. I'm sorry about this, no? Because the example doesn't show it. Even the original example for the fourth factor, this is the 6th factorial. Okay, L0. Okay. So pagdating dito, let me copy this instead, no? Say questionable. I have a question with this, no? Well, let me just remove this first. I'm sorry about that. Now let me just copy this properly, no? From the source. Saan naman yung ating, no? Wala yung ating diagram. Sorry, I've closed the diagram, no? Just a while, no? The factorial. There are two versions, no? Okay. Where are we now? This is L0, L1 is times L2, L times L2, L0. This should be and this. Wala itong looping. This is the one without looping. This is the one which we need, no? The one with looping. I'm sorry for that. Ito yung kailangan natin na may looping. This is the 6 factorial. Gawin lang natin 4, no? Let's do the 4. This is 4. Okay. Malay pa tayo, no? We still have time. So, this is 4, 1, 1 times L1. L1, this is 1. L2, this becomes 1. S0, this becomes 1. No, S1. And then this is a different version, no? L0, this becomes 4. L2, this becomes 1. Hindi pwede, no? Because this becomes 3. 3. And then you have S0. So S0, this becomes 3. L2. L2, this becomes 1. L0. L0 becomes 4. Ito pala. This is the one because this is still a minus. We should have a minus here, no? Okay? So this is dapat may minus ito. Okay. That's why it's an 11. Okay? Minus. No? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay. Okay. There's an error in the sample from SU, Stanford University example. Okay. Let me just delete this anyway, no? I'll upload I'll upload the update. Okay. Do you follow? This is the loop version. No? Now, remember that when we do this becomes -3. Do you follow? When we do any operation which will result to a negative number, the run-up lever will be set to 1. Do you follow? Okay. Can we erase this again? No. Let us trace this. Okay. And let me erase this again. There was something wrong with no. That's why I was lost. No? I'm sorry I didn't review earlier. But I will update this so you can get that. Okay. So first we have N0. Gawin natin 0, 0 po. 0, 0. Okay. N0, 0. Three digits because there's 0 to 99. Okay. So this is looping. Now, the looping is done based on a condition for continuation. Do you follow? Okay. When you do a loop, you repeat the loop based on two types of conditions, no? A condition for continuation or condition for termination. Do you follow? In this case, we are using a condition for continuation such that if the run-up lever is 1, we will continue or repeat the loop. Or if the run-up lever is 0, then we will terminate the loop. So take note, if you look at the documentation doon sa, sa Stanford, there's one line missing. Because when you say CB11, which it means count backwards 11. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. You follow? That's because there's a missing minus here. Huh? Did you get my point, everyone? No? There's a missing minus from the actual example. So partly it's my fault. No, I did not review it. And yeah. Anyway, I'm correcting it now. No. So n, can we trace this back? This is the looping version of the 4th factorial. The actual example is 6 factorial. It doesn't matter. No? So n004. Okay, this becomes 4. n001, 1. n002, 1. Okay, do you follow? Times. First, we have L001. So this, what is this? Anyone? What's ingress axis 1? 1. Very good. That's from Jillian. Jillian, okay. And from Earl. Whoever Earl is, no? It's 1, no? Okay, dahil 1 ito, no? And then we'll have L00, which is 4. Do you follow? So now 1 times 4, because that's a times, this will be 4, and then we'll have S001. So this will now become, this one will now become 4. Okay. So this is our next partial product. Okay. You follow? I think this is our decrement. And this is our next multiplier. No? Okay. Do you follow? Okay. We are here at 4. Next, we'll have a minus. Okay. So minus L00. What's L00? That's 4. Right? 4 pa siya. And then L002. What's L002? It's 1. So what's the result of the egress axis? Anyone? What will be this value? Right away, no? 3. Okay, from Zamora. Okay. Antabudlong. Okay, and Ivan Lo. Okay. Many others, no? So this becomes 3. Okay. S00. So this will be now our next multiplier, which will become 4. Do you follow? Okay. And then we will have a minus. Okay. Minus L002. What's L002? This is 1. Okay. L00. L00 is 4. This is the one which is important. 1 minus 4. This becomes negative 3. Do you follow? Do you follow? This is pass number 1. Here's pass. Okay. Do you follow? CB means count backwards 11. When will we count backwards 11? If the run-up lever is set. Count backwards if the run-up lever is set. When is the run-up lever set? Anyone? Kasi may run-up lever daw. Behind. It automatically sets itself on or set when the result is negative. Is this a negative? Ilagay na lang natin dito, run-up. Ito na lang, run-up lever, no? Klaro pa ba? Okay. So the run-up lever becomes 1. Dito, the run-up lever becomes 0. Okay. Dito, the run-up lever is 0. Do you follow? Do you follow? 0 ang run-up lever because the last result is a positive. Now here, the run-up lever is positive. So which means that it will count backwards. Do you follow? Everyone? So saan siya babalik? It will count, it will go back to this. Do you follow? We'll have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So we'll copy this again. We'll copy this. Okay. And this is now, instead of pass number 1, we'll now have pass number 2. Okay. Do you follow? Continue lang naman tayo, okay? Any questions so far? Okay. So may bago tayong i-introduce na variable, no? How can I masyadong naman, no? We format the cells and then we will justify. Can we do the justify? Wrap text. Okay. Okay, like that, no? Do you follow? Mas maganda yung merong ganito, kukulog. Okay. And then, let me just center this vertically. You follow? I'll upload the source, no? You follow? So, we are now on the second pass. Okay. Fourth factorial lang tayo, no? Times. Asan ba yung L01? Ito, sa G, no? Sa G. Okay. So, the last values are 4, 4, 1. Okay? 4, 4, 1. L001. Dapat i-ano natin ito. Let's freeze panes. Freeze panes. 940 tayo, no? Okay. Para hindi mag-ano. 4, 4, 1. Okay. Can we just write down the values, previous value, the last values here, no? Para hindi mawala, no?
Sir,
Yes.
may question po ako sa line 13 po. Bakit po yung S000 is 4 kung 3 po yung answer?
Asan ito? Ito?
Yes po.
15, line 15. 15 ba o 13?
14 po. Bakit po naging 4 siya?
Ay, sorry.
Sabi-
It should be 3. This should be
Okay.
3. Sorry, no? It should be 3. So this is 3, 4, 1. You're right. This should be 3. No? Do you follow? Thank you, no? 9, 10 lang ba tayo? Okay. Let me check. I'm sorry, no, if I ran out of time. 9, 12, no? So who did I miss? For our, ano? Hindi lumalabas yung aking, ano? Nandito. 9, 10. I'm sorry, no? So we'll continue with this next meeting. Okay. I'll upload the source and then you find out, no? I'll upload the source and then you can also watch the recording of other classes. Okay. We're 3 minutes off the mark. Thanks, everyone. Now you email me those who I haven't checked. Okay. Cartoneros, I'll check. Okay. Bye, everyone. Thank you.
Bye, sir. Thank you, sir.
Thank
Hi,
you,
sir.
sir.
Thank you,
Sir,
sir.
thank you, sir.
Hi, sir.
Sir, thank you
Thank
po.
you, sir.
Thank you.
Bye, sir.